right, welcome everybody. Welcome to this session, making data make sense in 2023. I'd like to introduce the moderator of the session, but before I do so, I want to thank Litmus for sponsoring the session and the speakers, and you for sticking around for a second day on the IoT World Manufacturing and Supply Chain Days. Dave, the floor is yours.
Oh, thank you, Lucian. Hi, Dave McMorran, Director of Sales Engineering for Litmus, and wanted to start by first mentioning we do have the Q&A panel. So any questions, please put those in there and we will be answering those. We have 15 minutes at the end to try to get to those questions, as many as we can. But first, what I'd like to do is introduce the panel, and I'll start out with Matt Wapada. Go ahead, Matt.
Hey everybody, my name is Matt Wapada, and I'm a technical product manager for Edge Solutions at Belden.
Thanks, Matt, and I'll pass it off to Dave.
Hey everyone, my name is Dave Griffith. You guys may know me from the technical work I do during the day job. I am a facilitator and a practitioner. I help organizations go through digital transformations that pay for themselves, specifically by finding profitable solutions and helping to execute that. Beyond that, you may know me from my Wednesday night show, Manufacturing Hub, in which we talk all about manufacturing, including about 90 minutes of all sorts of data conversations last night. And I'm super primed and excited for this.
Great, thanks, Dave. And Vatsal.
Hi, everyone. It's Vatsal here. I'm co-founder and CEO at Litmus, and I'm very much looking forward to this session. Thank you.
Great, thanks, everyone. So today's session, we want to talk about making sense of the data, talk a little bit about where we are right now and what you're seeing in the market currently and in the last 12 months. Then like to kind of talk about what we're seeing as the trends in the market, what's coming next, and talk a little bit about that. So to get started with that, I'm going to start with you, Dave. You just mentioned you just did a podcast on this. Like, what are you seeing in the market right now, and with your customers and manufacturers? You know, like, what are they doing with the data? How are they using it? What kind of things are you seeing in the market today?
Yeah, absolutely. I would say first, if you're an industrial or manufacturing organization and you are taking data and putting context to it and making decisions upon that, congratulations to you. You are absolutely one of the few as opposed to one of the many. Historically, and most of the time I see if organizations are collecting data, you know, it goes maybe to an Excel spreadsheet. We take our Excel spreadsheets, we sit in a meeting, we go talk about issues that we find. We say, yes, this is an issue. We go back to our own offices to go to kind of figure out what that issue, and maybe 2.5 weeks later, we have found the kind of the root cause of what that issue is, but we've already missed 2 or 3 or 5 weeks of opportunity and production along those lines. So I would say historically, and even like up until today, for the vast majority of organizations, that is what life looks like. I would say kind of the next step moving forward is taking that and moving from static Excel spreadsheets to maybe we do something crazy like put an Excel spreadsheet up on a board, look at live data, or more realistically, and hopefully we've got live dashboards that help contextualize some of this data, and we can go sit and drill down on what that data looks like and make decisions real time, implement those decisions real time, and execute on those so we can make dramatic effects in the immediacy.
Yeah, great. I mean, one of the points you made there was adding the context to the data. That's something that I talk about all the time, that the days of just having a value, maybe a timestamp, maybe a name to that tag, it's getting more difficult to analyze that data. There's a lot more tools that are out there to do that.
Mm-hmm.
So I'll throw it to Matt now. Matt, what are you seeing out there with your customers in manufacturing?
Yeah, it's a spectrum, right? And it's constantly at a snail's pace, moving towards the end goal that Dave was talking about there. There's, at the very far end of the spectrum, your data is just stuck in operators' brains. It's not like even on a screen or even in an Excel sheet. I mean, if you can get it on an HMI, that's a good first step. But then what happens is from the HMI, it goes to a clipboard. The next evolution might be to an Excel sheet. The next evolution might be to an MES system. So there's customers throughout that whole spectrum. Slowly, as costs go down and expertise goes up, more and more companies are moving further to the, integrated data. And I've been having some conversations recently with more mature companies, so larger, typically companies that are, have built the ISA 95 pyramid. The data's coming from their PLC, going into their historian, and then to their visualization tools, that are reevaluating that sort of stack that they have and seeing, do I need to send all the data through the PLC? Especially in regulated environments, it's really expensive to add a sensor. It's not just plug in the sensor and your data's flowing. It's plug in a sensor, add the tag, update the PLC program, update the historian, update your visualization. Very complicated. And to realize sort of the value of data, the predictive analytics and the dashboarding tool and integration with IT systems, there needs to be a faster way to do that. So these sort of around the PLC architectures, trying to realize this NAMR open architecture vision is starting to happen. And I say starting to happen in that we're dipping into some POCs, but that's like at the very far end of the maturity spectrum. So I'll leave it there.
Yeah, thanks, Matt. You said a bunch of things there. I could spend a whole hour just talking about one of them. But one of the things that I've actually been seeing also that you mentioned is, manufacturing, or alluded to manufacturing, we're still trying to solve the same problems, right? We're still trying to be more efficient, reduce costs, faster throughput, better quality, all those problems. It's the same thing. And I work at a startup, so a lot of younger engineers there. So I have to remind them that we're still solving these same problems. We just have better tools and more information to do that. So thanks for that, Matt. So I'll pass it to you. What are you seeing in the current state?
Yeah, I think the thing that Dave and Matt mentioned, they're spot on. Like we are seeing a spectrum of different type of customers. So somebody who is a little bit more advanced. So customers coming from process industry, they are going to be more advanced because they already have historians, they already have data loggers in place for compliance reasons or any other reason. So they are one step ahead. That means all they're doing is, let's contextualize this data, let's normalize it, let's push it into a central architecture, let's store it somewhere, let's store it in the cloud if it's affordable. They are already doing that journey. On the other side, we are seeing on the discrete, where customers, they are starting from day zero, which is all of my data was just collected and dumped because nobody was storing that data. I had that data available, which was an HMI or SCADA system, but it was not persisted beyond 24 hours or 7 days or whatever it is, but they do not have the history. So that now they are getting started with that point. And we are seeing countless customers implementing our products just to achieve that first connectivity piece. Then the second step that they are taking is take some out of the box solution, push data into cloud environments, and let's start seeing that data. So that's where most of the customers are. I would say about 50-60% customers, they are in that spectrum. Others on the other side, there are some advanced customers, which are mainly, I already know what my data represents. I already know what my processes represent, what my assets represents. Now allow me to utilize that data in a more complicated machine learning or complicated pattern identification environment. So yes, we start from one point, which is just making sure that the data is valid before we do anything else. Other side, our data was already valid. Let's do something with it. So again, it's a spectrum.
Yeah, I would agree. I mean, I'm talking to customers that have no data collection at all, have never done it, all the way to, hey, we're already advanced. We need to get the data. We're working on machine learning and going down that process too. So one of the things I heard mentioned a few times already and is passionate for me is adding context to the data. So Dave, I'm going to throw it back to you. Like, when you talk about adding context to the data, what are you referring to? And before you get to that, I know, unified namespace, very popular topic, very hot topic right now in IoT. That does part of it, but I'd like to get your feedback on it and your thoughts on adding context to data. Go ahead.
Yeah, absolutely. So when I look at adding context to the data, it becomes, what does it mean to the real people? So many times, depending upon the size of the organization, the folks in charge of the data, right? So the process historians, they're sitting in the engineering building. They are not in the middle of operations. And the assumed context of what a tag or what this information means may or may not relate to what is actually happening. So a good example of this, and we can go into the execution side, is I was working, with an organization And the organization, we pulled some data, we did some time tests, and they were taking 40 or 50 hours a week, every week downtime, because the previous step, well, they were taking 40 or 50 hours a week in what was changeover, right? So from one batch to the next batch. And you go look at it, and initially, the people, if you just look at the raw data saying, why is it taking 40 or 50 hours to change over, that becomes a pain point, right? That is millions of dollars a year to this particular organization. And so we go through the process of saying, hey guys, why are you taking this? Like, we go to try to literally add the context, and many times the context is on the plant floor, asking those people, as Matt and Vasal mentioned, in the operators' heads, like this is the only reason we know what is happening. And so it quickly became, hey, we're taking all of this downtime because the step before our packaging process isn't getting things ready, right? And so you go, and so you have to take that step, that next step, to go to try to continue to add the context to the data. And they're not ready because 3 or 4 other things are happening, and they don't know, because the schedule changed so much, how and where the packaging is in relation to the current run. And so we don't know what is happening. And so we were able to go through and kind of solve that problem by putting basically a simple dashboard of saying, hey, this is where we are on this particular run. We need the next tank to be ready at X time. Here are the check marks for sign-offs. And so we know that things are ready. And just by immediately kind of intermixing those two groups, we were able to solve, 20 or 30 hours of downtime a week. But that is kind of taking the hey, we've got a bunch of downtime because we're not ready to run, and going and driving down into the root cause of, hey, why are we actually not able to run? Let's go solve this problem and provide, millions of dollars for what basically amounted to, I don't know, half a day's worth of work and an iPad slapped on the wall.
Yeah, it's funny how some of those low-hanging fruits can, really pay for themselves right away. So Matt, yeah, let's why don't you continue on that thought? What are you seeing with customers, and when they start talking about adding context to the data, what are you seeing?
Yeah, Dave did a good job of talking about what sort of value is created there. I think if you look at the flavors of context, if you will, if that's a thing, there's more data from the sensors themselves, and then there's more data from the supporting systems around the sensors themselves. And back in the day, you had 4 to 20 milliamp signals and discrete on and off. Like, it's electrical signals as your data. As sensors have become smarter, starting with Modbus, but now HART and IO Link, and eventually, everything over TCP/IP on single pair Ethernet. This day, there's going to be more data, and I think the even more important part, not necessarily that it's more, but it's more accessible. And this is like the biggest problem. Like, a lot of the times the data is there. It's just not really easy to collate and put together to make the dashboard that Dave was talking about. I'd love to hear, Dave, like the pain points and the tools you use to get all that data together, because it's hard. And what we're trying to work on at Belden, a lot of our customers are trying to figure out, is how do I streamline this process of accessing the data that already exists without having to have somebody manually go in and type in Modbus registers and add a tag name to it, and then make sure that correctly maps to all the databases that I'm sending it to. Like, we as vendors need to make it easier for customers to access this data. And once that access problem is solved, the contextualization becomes a lot easier.
Yeah, I agree with that, because one of the things you're starting to see also is, you talk about the data that's already been there. I mean, I wonder how many historians are out there that have been collecting data for decades that nobody looks at, right? Partly, I think, because it's been hard to do, and we need tools that are better to do that. The other thing, you start seeing technologies, and these are not new technologies either. They've been around for a while, but something like IO Link, you mentioned discrete sensors. All of a sudden, there was all this data in the sensor that just was never exposed. All was exposed was on and off. Now you have data like contrast, and you can start, and how the mean time between failure, and that kind of data can be actually in the center and unlocked. But again, you run into that same problem, like, how do I gather it, right? How do I collect it? How do I analyze it? How do I put context to it? How do I store it? Like, all those same questions and like architectures come up as well. And clouds helped, some of that. Edge is helping with a lot of that as well. So it depends on that. So I'll pass it to you now. Talk about context and data and what you're seeing.
Yeah, so I think like we have seen a journey from customers. So if I go back, like, let's say 3 years, which is 2018, 2019 timeframe, customers were just trying to figure out what metadata do I need to contextualize this sensor or this variable or this PLC with tag or this SCADA variable or this MES variable. They're all trying to figure out what metadata and data combination do I need. Over last few years, there is enough maturity in the market because there is a lot more awareness about different use cases. So now they are coming back with, oh, I want to do OEE monitoring dashboard, or I want to do this MES integration because it might shorten my time frame and get me out of my Excel files. Or we have one of the large automotive tier 1 customer. They actually integrated their production line, their contextualization service, which is manually built database driven contextualization, to drive active reporting to their suppliers and to their customers. Now that use case force them to integrate or contextualize the live PLC data with ERP system data and some sort of other monitoring data, and then they combine everything. So my point is, contextualization is mainly driven by use cases more and more. Customers, they already know what baseline data and metadata that they need. From that point, that can be just key value, timestamp, or what shift they are running, and like whatever the baseline is there. But then they start adding more and more variables based on the use cases that they are doing. One of the big example is cloud companies. They have started a very sophisticated digital twin frameworks. These digital twin frameworks also opens different possibilities, which is bring more data from multiple different environments, something from Litmus Edge, something from SAP, something from SCADA systems, doesn't matter. Just bring it so I can create a proper digital twin out of it. So yes, just use case driven contextualization is something that we are seeing more and more.
Great. Thank you very much. So, I mean, along those lines, some of the things that I've seen with context, you mentioned like ERP, and, I've looked at it, the days are going away where it's just tag name, timestamp, and a value. I want to start adding like, what SKU was it? Maybe what shift was it? What operator? What machine was this at? So it's not just, like the unified namespace of saying, hey, here's where the data is coming from. I think that's great. I mean, we should have that, and people should be implementing that to create standards around it. But I'm also looking at the other side of it as more information model to enrich the data that you're getting and being able to work with it. Because I think if you actually put context to the data, it makes it much easier for maybe a plant manager who's not a SQL expert or have the technical background to go look up and see what that data is, because the tools are out there to help make that job much easier now. And if you get the context right, you can actually open up and democratize the data so people that are not experts in the technology can still access that. So that's something that I'm seeing and promoting as well. So, well, great.
Yeah, you must be in 2030 right now.
Yeah, maybe.
And
at least I'd like people to do that, right?
Yeah.
And if I may continue, I would say when you look at any sort of manufacturing industrial plant, it is a daunting task, right? Like all of the things that we've just said, it is a daunting task. You look at it and maybe it's only 5,000 tags or 10,000 tags, and you're like, this is 2 or 3 years worth of work. I would say go pick the lowest hanging fruit, right? Go pick either your most important machines, the machines that give you the biggest issue. If you have some sort of data to look at downtime, go look at a Pareto chart and go pick that 20% of issues that cause you 80% of downtime or 80% of material loss or any of those, and start very specifically with those. By starting with those, you're going to be able to get some of the quick wins as we've described. And as you guys are going to find, you're going to get buy-in from further up in the management chain. And then from that point, you'll have more resources, maybe people, maybe money, in order to kind of continue along the path. You'll be able to get more of those smart sensors, as Matthew had mentioned, and you will very easily be able to continue your journey. So while we talk about context and data as kind of this big picture, the big picture is really daunting, and you have to start small. And by starting small, you're going to be able to continue.
Yeah, that's really a great starting point. Go ahead. Sorry.
Yeah, not to completely derail us here, but I think what Dave said and what Vatsal said kind of come together, where there's this digital twin, this idea of a digital twin of a whole plant. Like that could be sort of trying to eat an elephant if you start with that and try to work your way backwards. And so it seems like, Vatsal, you were saying that a digital twin is the right framework or tool to provide this context, but how do you start with a digital twin? I know it's sort of a ephemeral term, but like, or ambiguous.
No, you do not start with digital twin. That doesn't, in my opinion, that's more like an end result. The thing that we normally start with is really about raw data. Understand that raw data. Create an internal knowledge base around that raw data. Collect it, store it, process it. Normalize that. That means temperature coming from Rockwell versus Siemens. It has to look like temperature. It's not like Rockwell hexadecimal temperature versus Siemens, like Siemens decimals temperature. Like just normalize everything. It needs to look exactly same. Those are the things which are required. Then make it available to simple database, SQL, NoSQL database, doesn't matter. Visualize that data. Then we are talking about, oh, you already know this cyber physical ecosystem that exists. Now let me visualize it. Let me simulate it. Let me run some specific models on it, machine learning models and more. That's where you end. It's not something that you get started with. It's just my 2 cents on digital twin. Again, it's hyped at up to a point where a lot of our customers, they think that it's a starting point, but as they start implementing it, it's least of their concern from day zero. That's again.
Yeah. I mean, that's a great point too. And again, where do you start, right? You have to start with the collecting of data and keeping it raw. But I think having that use case, having that value as a goal and know what that is ahead of time is where you really need to start with that. Then you start collecting the data, then you transform it into the way that you really need to use it. And that's one of the things that I see the evolving is, again, adding context to the data. So instead of me just storing raw data of machines running or machines not running, you know, in the downtime use case, how about we actually track what that downtime is, you know, as it's evolving, as it's coming in a real-time analytic, and then my data model then becomes my downtime record, right? That's my downtime. I store that into a database. Now all of a sudden, a plant manager can go in and easily search that data as opposed to writing some, you know, crazy query or hiring somebody, buying some package to do that application for you. That you can actually get the data in a format that makes it usable for a regular user, you know, on the plant, on the manufacturing floor. That's not a SQL expert kind of thing. So that's one of the things I see. And Dave, to one of your points is like I'm a controls engineer, so feedback loops are always a big thing, you know, and the software is not really solving a problem, you know. All it's doing is exposing the data, exposing the problem, but we are closing the loop, right? Because the closing loop is the visualization of the problem, and then somebody's physically going and solving that problem. Yes. Versus like a machine learning, which machine learning is actually closing the loop, you know, at the machine level to improve quality or in throughput or those kinds of things. That's kind of where, you know, this information is still closing the loop. It's just how quickly are you doing it? So, well, great. Thanks, everyone. I think I'd like to shift to now, like what we're seeing in the future. What are the trends that we're seeing? We talked a little bit about that already, but one thing I want to specifically bring up is what trends are you seeing with the convergence of IT and OT? You know, how are you seeing that relationship change and those kinds of things? So Dave, I'll throw it back to you. What are you seeing out there in that relationship?
Yeah, absolutely. So I would say as recently as maybe 3, 4, 5 years ago, it seemed like there was a lot of friction between IT, OT, right? We would talk about IT, OT convergence, and the questions would be, do we need to converge IT and OT, right? Like, do we need to do this? Is it important? Is the juice worth the pain, if you will, of going through this process and upsetting people and maybe losing people on both sides? Is it worth the value that we get? I feel like the majority of the organizations that I work with, the answer is a resounding yes, right? So I feel like we have gone from the should we do it to the it is imperative for the growth and survival of our organization in order to converge IT and OT. And I have found the rise of kind of people, if you want to call them like OT engineers or OT network engineers, who are able to kind of speak both on the IT side of things and the OT side of things. in my experience, especially with like corporate level people, it is not the fact that the IT people don't want the ability to use artificial intelligence and machine learning and cloud-based tools and all of this. It's that they don't, well, it's two things. One, they don't understand the OT side because we've got all different types of protocols, because the switches and hardware that we have on the OT floor run tremendously different than what they do on the IT floor, right? So if we're above 5% on an OT network switch, we are seriously looking at losing data packets. And on the IT side, they're generally happy running them at 95% for a variety of reasons, right? So I would say that the issue is that they don't understand what we do on the hardware software side. And two, typically they don't want to be responsible for it. So they're worried that if they say yes and rubber stamp it and maybe open some ports and funnel some stuff up to the cloud or whatever that looks like, it is going to be, well, now they own it, right? And so now the job that historically on the IT side is people who feel like they're underworked and overpaid, which may or may not be exactly what the people on the OT side feel as well. It becomes, now we've got twice the work or 10 times the work because I don't understand any of these programming languages or the things that they're trying to talk about. And what's a PLC and what is this weird ladder logic stuff? And how am I supposed to figure out what this is and how it works and how we push it up to the cloud? And am I going to be the person who gets called when there's an issue? So I have found that if you can get past that and have the conversations and provide a path forward, generally, not every time, but generally on organizations, the two groups find a way to move forward and realize for the good of the organization, we need to, for lack of a better term, meld our data types and our solutions, and we need access to the cloud. And we realize that a theoretical air gapping of the OT side is not realistic or not possible. So I have found that we have significantly and happily kind of moved into harmony when we can have those conversations. And I have many more thoughts, but I'm going to let everyone else talk about it, lest I run us out of time.
Like I said, we can spend an hour just on that topic. So Matt, let me want you to take a stab at that question.
Yeah, a quick one that sort of riffs off of what Dave was saying, that it's different. IT and OT switches and software and hardware are all different. The problem that I've run into most recently is a little bit of IT trying to force the tools that they use for securing and managing their IT equipment onto the OT equipment. And at Vatzel, we actually discussed this a few weeks ago. Like, this is something that is back to that fundamental reason that Dave talked about. There's just a misunderstanding. Like, we can add an agent running on your switch that does cybersecurity. Well, if it increases the compute load to 15%, then we're going to start losing packets because this is all real time. And so that's the pain point that we're running into most, like, immediately with me. Now, the good thing is they're talking. They're trying to get this thing to work together, but it's just going to take some time to figure out, like, this can't run Norton antivirus. It's like not made to do that. So that's a tangible example of the conversation I've had recently.
Great point, Matt. Thanks. Vatzel, go ahead. Yeah.
So I would say two different things. So let me continue on Matt's start. Again, we discussed this at length. The first point where IT and OT converge, it's on network. That's what we have been seeing across customers all the time. It's like they will stop. Like the general goal that both of them they want to achieve is OT environment is secure, IT environment is secure, OT environment is well managed, IT environment is well managed. The tools at day zero that IT has, they are far superior than the tools that OT has. Again, this is going to open up a whole lot of discussion here, but the idea would be the IT tools for networking and other things, they are superior. They always have been superior for whatever reason, compute unlimited, compute availability, or whatever they had. So that's first point that they converge. And the second one, the big and interesting one is they converge on data. It's like this is one of the large food and beverage company out of Asia Pacific region. The idea was for them, like IT team, they invested substantial amount of money in a cloud lake house or cloud data lake platforms. They were looking for more and more use cases to drive that specific data lake services that they were creating, or the skill sets that they were creating. So they kept on asking OT teams, bring us more data, bring us more data. We are going to help you get some ROI out of that data. And at the same time, we're going to get ROI out of our data lake investment that we are doing. They started with financial services, then they went to supply chain, and then they went to OT teams and give us the data and we're going to work with you. So that was a beautiful combination or convergence of IT and OT. And we are seeing that consistently. Again, network is first, which is more like a forced partnership. Data is second one, because once again, IT has better tools available at their disposal to understand, analyze, catalog that data, calculate the lineages of it, do machine learning, better skill set, better tools, better infrastructure. They have it. So it's, again, it's more like it's not optional. It's more like it's going to happen sooner or later for both of those points.
Great point. And to kind of spin off on that as well, is what I'm seeing is, once you have that data, like you were talking about, Vatsal, you've got the data, the IT group, in my opinion, is usually better suited to work with that data. Not always, right? Because they do need that subject matter expert down on the floor to understand it, but to work with the data are much better, better equipped to do that. So, to deal with like SQL and NoSQL type databases and queries. And you see, I'm starting to see like these emerging tech type of groups, and they are living in the IT group, or your data scientists are usually living in the IT group or some other group, not in the OT group. So I'm actually starting to, I can see a trend, just a very, small start to this, of IT going from this kind of enemy cost center to now more of a, I'm going to help the OT group and start working together. Yeah, there's still security that there are concerns. There's the networking, like you mentioned, but once they get to the data and they can actually start helping the OT, I think we're going to see that change. And when that starts to happen, it's going to happen very quickly.
Yeah. It does. And again, to the previous point, contextualize and normalize data helps them understand that.
Right.
If you keep on dumping Excel files or CSV files and tell them to go figure it out, it's just going to delay that data-driven decision-making journey. But if you normalize that data, whatever format you want to use some standard JSON schema, or some Sparkplug format, or OPC UA format. Again, not that I'm recommending any of those, but like the idea would be the idea would be to make it available in a way that they can utilize it and give the results back rather quickly.
Yeah, you make a great point on the contextualizing data, because I think there isn't a right solution for that. There are multiple solutions for that. Mm-hmm. Your data context could be just, where does the data come from, value, and a timestamp. That could be all the context that I need, right? Because I'm putting together a dashboard for real time. But to do more deeper analytics, to say, hey, why was my downtime this bad? Why, how can we improve that? I think that's where the greater context starts to come in. So it's not that there's a either or. It's like, it depends on your use case. It depends on what you're trying to solve. Maybe you're doing both. You probably will be doing both of those. And it all depends on how do you want to use that data. But the tools that are out there now are making that so much easier to leverage that data.
And if I can add to that, there is an important need to contextualize the data before we go shove it up to the IT and the data lake, because when they say we want everything, what does everything mean? Does everything mean that they want 1 million PLC tags at 1 millisecond? Do we want it at 5 milliseconds? Do we need it at an hour? Because there are, depending upon what the variable is and what the sensors look like, I mean, an hour, very realistically on some of these things, could be a better time interval in order to send data, as opposed to a millisecond, because we may see milliseconds on temperatures pop up and down like crazy, and we think on the IT side that it throws it out of spec, but it's an outside air temperature, and we just want to make sure that we normalize the inside air to what's happening outside, temperature, humidity wise. And what we really need is we really need that once an hour to make sure that we're within plus or minus 5 degrees. But if we go through the process of pushing it at 1 millisecond, one, it's going to be super expensive. It's going to overload. It's going to overload the data lake. It is going to cause issues on our time series or process historians because most of them are not prepared or equipped to be able to take data quite that quickly. And so we need to go through and contextualize that data before we just go shove it up. And so when people say send us everything, we need to go dig in. And generally when people say send us everything, after I'm done kind of chuckling to myself, we have to have the conversation of like, let's go figure out what we need to do to contextualize it so we can give you the correct quote unquote everything before we go through the process of just confusing systems that are not equipped and prepared.
Yeah, agree. Batal, did you have a comment on that?
No, like I was just like when I heard it's expensive, the infrastructures, they are not ready. Yes, that's 100% right. The infrastructure is as of this moment, unless you know how to negotiate with the vendors, it is expensive. The idea would be like the edge computing is going to help. Like this is what our customers are doing. They are still collecting 10,000 variables or 10,000 PLC tags at every 1 second, but they're not sending everything to cloud. It's more like they are calculating averages. They are doing some correlation. They are creating a specific array. They're doing change of value, everything right at the edge. We are seeing them implementing those solutions. Then they, once those things are done, they are integrating the points out of those 10,000. I'm just going to integrate 100 to cloud. And that's what it matters, which is you're going to have a dashboard available for 10,000 at edge. And you're going to have mission critical dashboards available at the cloud, which is just made for 100. Again, the architecture is 100% right. That's exactly how it's supposed to.
Great, thanks. So one of the things we've kind of touched on, with trends. I mean, everybody's been talking about machine learning and talking about AI and modeling and that kind of thing. It's like, what are you guys seeing with that? And let's keep this quickly as we're running out of time a little bit.
Absolutely. So when I look at that, I look for most industries as kind of future looking for a variety of kind of everything that we've talked about, recontextualization. The majority of clients that I work with are not quite ready for that. Now, I will say I've seen, 2, 3, half a dozen very industry specific. So I know pharma is kind of using that in process so that they don't have to use quality testing. That's, I don't know, machine learning, long regression analysis, however we want to kind of describe that, of if they know that the inputs are within this, circle, we know that our end output is good. I know a couple of organizations who've kind of built some of their own machine learning, maybe even artificial intelligence, because they're already running at, that 95 to 99% OEE. And so they're trying to squeeze the last, 0.2% out. And so for them, spending hundreds of thousands of dollars is certainly worth if they can squeeze the extra couple percent out. So I think for most organizations, focusing on creating good data, creating clean, hygienic data, having contextualized that is going to help them with a bunch of low-hanging fruit in the immediacy and is going to allow them to leverage these tools as these tools get better and more relevant to their industries and to their facilities in the future.
Yeah, I think also to add to that is easier to use and education, people coming out of schools that have already touched on, Python or R and have already touched on very small specific machine learning. Thank you for that, Dave. Matt, do you have anything to add to that?
Not much. I think you did a really good job of highlighting the fact that lower hanger fruit needs to be picked before you go for AI and ML. The only thing that I would add is, well, I guess 2 things. One, a lot of these manufacturers aren't going to have data scientists or AI people that know how to use AI in their factories. And so they're going to be looking to buy, they're going to be using AI, but not knowing that they're using it when they buy a sensor or they buy a system that improves their operations. And I think that that's kind of what we need to do as vendors for these guys, is we don't want them to have this really advanced skill set in order to be able to derive value from what we're giving them. And so, that's what we're keeping in mind when we're looking at AI and ML, is like, how can we simplify it and make it sort of plug and play to derive value and not necessarily build a new tool that somebody has to use and support.
Great point. Go ahead, Vetzal.
Yeah, no, again, Matt is 100% right. The vendor-driven, the pre-built algorithms, they are currently what we are seeing a lot. Anywhere from pattern matching all the way to some predictive maintenance items, prescriptive maintenance items. They are running inferences right at the edge for near real-time use cases. They are running inferences in the cloud for visualization or just like for further machine learning algorithms that they are building. The idea would be, I think, there is a textual data, which is more JSON key value, but there is also vision and audio data. In terms of vision processing itself, machine learning based algorithms, they are popping up every single day. If they have a specific use case for one of the oil and gas midstream use case, they were actively monitoring a specific type of leakage. There were sophisticated cameras on place, and they were trying to keep on understanding if there is a specific spill. You can do that very well with machine learning, identify the specific patterns, identify the specific scenario, train the models, and keep on repeating it across like in a distributed way. There are sophisticated tools available for it. So again, textual side, it's improving. There are more and more use cases which are popping up, but video and audio, it's already there.
Yeah, I think people try to think of machine learning and they're thinking in the future of, autonomous robots and those kinds of things. When I'm looking at machine learning is just a simple pattern matching to say, hey, I have downtime. I've got 10,000 tags that look like my downtime occurred here. The machine learning just says, hey, I think these 5 tags are mostly related to your downtime. I don't know which one it is, but basically just tell the operator that, hey, go look at these 5 things because they're more weighted towards what's causing your problem, or it's finding that pattern. So it's something simple like that. It doesn't need to be this, run the entire plant and make it efficient. It can be something very simple to just a tool like Matt you're talking about, giving a tool to somebody that helps them with their job, that helps them be more efficient, improve quality, and again, those same problems. So agree with that completely.
Can I squeeze a question for Vatsal? I'm just curious. You talked about these new types of sensing, these vision and these audio sensors. Are customers sending this data through the control system, or is this another around the PLC way that people are collecting data?
Around the PLC way. So like this would be the new sources of data. Modern sources of data can be video, some existing audio sensors that they have. But what they're doing is those video systems, they don't know the details inside the assets itself. So they are taking the PLC tags, PLC variables, or automation system variables. They are merging it with the video data that they are getting. We saw that actually live as an example recently, where again, all the video data was contextualized with the metadata coming from the control systems. Now, when you do the machine learning, you have like verification algorithms, they get very easier. That means if somebody was showing that why the CNC machine went down, now you have a video proof that somebody changed the feed rate, and then you have the outliers which are coming from the controls, like CNC system variables itself. Again, this is the beauty of it. You don't have to teach that machine learning algorithm everything. It can be semi unsupervised, but yes, it is purpose built. It is still narrow AI. It's not HAL 9000 just yet.
Great. Thanks, Vatsal. So, and great question, Matt. So just kind of a lightning round here as we close up before we get to questions. Dave, what are your hopes for the next, for the next year and what you see with data?
Yeah, absolutely. I guess my hopes for the next year are that we're able to go look at real-time data, and that we've got our OT side and we've got our operations side going and having conversations to look together to put context to the data, and then creating actionable items from that data to provide extreme value to their facilities.
Great. Matt?
Yeah, my hope is that deriving value out of these manufacturing data will become easier for customers, because like at the end of the day, manufacturers don't really care about how the data comes into the systems. They care about making more and better widgets in a safe and sustainable way. So if we keep that in mind, like easier can mean a lot of things. Like it's easier for them to adopt this because they're more confident that the ROI is going to kick back to them. And I think that's on our shoulders to make sure that they see value from the manufacturing data. And then it could also just be lowering the soft costs associated with testing this stuff out and realizing sort of the low-hanging fruit that's out there. So making it easier for them to see value, I guess, is the high-level goal.
Great. What's up?
Like one big side of it is like us as an industry, we are very small. It's not a giant industry. We really need to come to some sort of common ground on what is the security first, scalability first architectures that everybody's building. We don't have to create and recreate the new protocols and new standards every single day, but there needs to be a general baseline that everybody can follow. Again, however we do it, whatever we do it, whichever organization initiates that, but we really need to guide the industry as a whole, how to create a secure, scalable, repeatable, good architecture, which is future ready. It's just my opinion on like where the industry needs to go towards.
Right. Yeah. I know security is definitely a concern. I can see the RFIs that I've seen from 3 years ago to today have really, you know, the security tab in the Excel spreadsheet keeps getting longer and longer, and making sure we can do it that way. So yeah, I think I would align with you know, what I would like to see is what you were talking about, Dave and Matt, is like that, you know, contextualizing the data and creating actionable items from it and just making that easier. Because I still think there's a mindset of just saving, you know, raw data and trying to figure it out from there. And I'm like, there's so much more you can do with that data today and easy there. So great. We're going to go to questions. There's a few in here. Forgive my pronunciation or mispronunciation of names. But Jaroslaw, SQL and RDBMS databases still dominate in IT. NoSQL are more flexible, but still is a niche. What do the experts say about data evolution of NoSQL or SQL? Dave?
So I will say that I typically don't get into the weeds on which database we should and we shouldn't use. Typically, when I am working with end users, it is the question of what are you guys more comfortable with? What does your IT staff currently use? I don't know if there's a huge value in using one flavor of a SQL database versus another flavor of SQL database. I will make the comment while we're talking about databases is that especially on the OT side, that there can be the conversation to have around time series database versus SQL database. And I think that it'll, again, on the OT side is a more important conversation to have. And do we spend the money to go build or purchase a process historian with a time series database than what flavor of SQL should we go through?
Right, I agree, because some data is great in the time, you know, it needs to be time series database. Other data needs to be SQL. So I know there's a fight between NoSQL and SQL and time series, but there's no one solution. It's pick the right database for the, you know, the purpose, right? So it's going to be a combination of those. So thank you for that. Next question from Nil. Digital twin is a great concept and tool. Any comment on the current price point to get there? I don't know if we want to get into pricing, but one comment I'll have on digital twin is that was one of those, I think, terms that the marketing groups got a hold of and kind of just went all over the place with it. When somebody says digital twins to me, where we're at, I think in the industry right now is more data model driven. So like what is that information model? What does that data model look like to get the data into a format and add context to it, enrich that data so that it makes it, you know, more usable than just having that raw PLC tag with maybe a timestamp on it. So Václav, if you want to maybe comment on that.
Yeah, like once again, exactly as Dave mentioned, which is more like a concept right now. But digital twin, in my opinion, it has a few different pieces that you can address. You don't have to do all of them at once. It does start with the data models itself, then asset models that you're going to figure it out, hierarchy, ISA 95 that we have to figure it out. Then on the top of it, visualization modules that you have to build inside digital twin. How do you store that data? How do you process it? How do you visualize it? That's also part of the digital twin. Then we go one step further, which is once it's visualized, how do you simulate it? Can you trigger it? Can you make the specific change without going to real-time systems? Just simulate a specific portion of it. Yes, then it's you are already like 80% there. Then it goes like once again, it goes towards more like this is my cyber physical system. I'm going to modulate it to see how I can improve efficiency and all those planning. But again, once again, you don't have to do all of them at once. It's more about just figure out the data model, asset models, and then a visualization aspect of it.
Great. Thanks, Faisal. Hey, Matt, this question will be to you. It's from Massimo. We're talking about POCs and getting commitment. A lot of companies, they have KPIs they want to measure. Are you demonstrating the KPI, the ability, or the technology, or what have you found successful?
For a POC, yeah, I mean, a lot of the times the KPIs aren't going to be met until scale happens, and POCs are usually a single line or a single plant. So if you can prove value on a single line or a single machine, then it's pretty easy to scale. The problem is getting in, especially on bigger clients, to be able to do a POC on a single line can take a year. Like getting your hardware certified, making sure that the network access is correct, and making sure that you have integrations with the systems that need to visualize the data in order to generate insights from it takes a long time. So it's patience is required, and the ability to navigate bureaucracies, especially in very large organizations, is also something that's required here. Not to mention the fact your technology needs to be able to prove an ROI. But those are some of the soft things that you have to consider and think about when you're trying to go into a POC and help them realize value.
Yeah, and avoid POC purgatory, right?
Yeah.
Another whole hour segment. Question from Daraj. I'm going to point this to you, Vatsal, because it's a comment you made that you might be in 2030 when I said that. So the question then is, like, how do you convince stakeholders that are not very happy with using twins or cloud platforms?
No, but you once again, the idea would be, the reason I made that comment is that there are a lot of different steps that we have to take to get to that point where namespaces, unified namespaces, or the centralized architectures, they make sense. But it, once again, it doesn't really have to be all-in approach. So like, how do we convince the stakeholders? We are in a fantastic place in the technology world right now, where we already know the journey that we are supposed to take. Collecting data from industrial systems, understanding that data, visualizing it locally, making it available to cloud systems, all of those things, you should be able to do it in less than 1 day. How beautiful is that? So like the comment about 2030 is more about, you're going to go on central, you will have namespace architecture available where ERP systems, they are consuming the digital twin, and you have a supply chain figured out behind it. None of those things is required at day zero. It's really all about figuring out a journey and make it in a secure, scalable, repeatable way, so you can scale it from one site, one location, to hundreds of locations in matter of months or matter of weeks. Yeah, that's the idea.
Yeah, I'd also look at it from the standpoint of the technologies are out there now that you don't necessarily need cloud to do some of the basic use cases, but cloud really helps you from the standpoint of that scale, right? That all of a sudden you can connect all the plants together and have that single point of truth for all your plants and have all that data in one place. Plus there's the tools that we're going to start going down the machine learning path and the anomaly detection and those kinds of things, that high compute, high memory requirements, you're really going to need cloud. But I think you can do a lot of those first steps, locally, and not even have to work with cloud. So I think really it's not about convincing them to use cloud. It's more of convincing them about, like, get the data and prove out a use case. Then you can talk about how are you going to scale it. Because I've seen many a solution that somebody came up with, didn't look ahead enough, found a solution, and then the manager's like, this is great, now do it at every plant. And they're like, oh, now what? Right? So
and that does come very often with the open source components. Right now, we, like in current times, there is always a build versus buy decision that we see, once again, for the edge first approach, or I'm just going to design something by myself. Most of these things, they are going to require substantial investment in maintenance, as well as creation of the product itself. Once again, to answer your question, exactly as Dave said, it's more about figuring out a journey. Without cloud, you should be able to achieve it up to a point.
Great, thank you. Another question from Newton regarding UNS. So the question is about a lot of this data, might already exist. Maybe it's in an MES, maybe it's in an ERP, maybe it's in a historian, right? How does UNS affect those types of things? So Dave, I'll pass that to you.
Yeah, absolutely. And so I'd read Newton's question as well. And I think UNS is important to kind of connect and correlate and give everyone the ability to contextualize all of this information across a variety of different systems. So sometimes we'll see the ERP has very kind of business centric information, and the MES will have different information, right? It's got OT floor, but it may or may not have quality. It may or may not have a variety of other systems. So I think that the UNS or modeling tools such as that will have the opportunity to help us leverage kind of the contextualization across the entirety of the organization. And I think that is important. And then as Newton had mentioned, kind of how do you go prove that if you say we already have this information? I like to ask a lot of questions, right? And so I like to ask the questions of, if we have this information, why aren't we already solving these problems? And so if you go 2 or 3 steps in, you can kind of drill down to the root cause of, we're probably not presenting the information in the way that people understand. And so I think that the best way to prove that you need any sort of technological solution is to pick some low-hanging fruit and go show people, this is a problem that we have. This is how we solve the problem. This is how we think, kind of to the last point of how we can go scale what this problem is across, this facility and the other facilities within the organization.
Yeah. The way I look at UNS, the Unified Namespace, really just creating a standard around where the data is coming from. But I don't look at that. That's not solving the context of the data problem, right? There's still another step, in my opinion, on that. And you made a comment there, because I run into customers, and when I first heard about IoT, it's like, what is IoT? Collecting data from all these different equipment, storing it, analyzing it, visualizing it. I'm like, we've been doing that for 30, 40 years. What's new about that? And you bring up a good point. Is like, all that data is there. Why aren't you using it? And usually the response to that is, it's hard, right? It's all in different locations. It's not accessible. It's hard to, it's the Excel spreadsheet and CSV files and massaging data. Spend 80% time just getting 80% of your time getting the data in a format you can then go and analyze, right? So I agree with that completely. And we have just a couple minutes left. Like I heard a comment, Matt, I'm going to throw this to you. I heard a comment that if the data volumes in the IoT network are more than 5% of the switch capacity, then there is a risk of data loss. How can this be? If this is true, then statistically data should be, could be lost at any time. I guess really just talk about the data loss and what you're seeing in the OT side versus IT side. And Dave, you can comment on that as well.
Yeah, I'll give a high level answer and then throw it to Dave to get into the weeds. But like, if you lose a packet in a motion sensing system, you could have a robot crash into a wall. If you lose a packet when you're sending a email across an IT system, you're losing an email, maybe, probably not even. So the critical nature of the bits and bytes that are flowing over an OT network requires more prudence when looking at utilization and packet loss. I mean, utilization is sort of, I think, a high level metric. You have to dig underneath of there to see really how the traffic is going to the endpoints and how the routes are behaving. And so I think that's what Dave was getting at when he made that comment. And I mean, I'll throw it over to you, Dave.
Yeah, absolutely. I would say 5% isn't like a super hard and fast rule, but absolutely once you get, I mean, again, we can't run 95%, and there are, I guess I'm not a network expert. I do know a bunch of OT network experts. I've had a couple on the show, and these are kind of conversations that we have had as we go through and talk about this. But yes, there are lots of organizations that have lots of issues, and many of those issues can go down to what the OT network volume looks like. Go down to what the OT network volume looks like, and a couple of minor adjustments could save significant opportunities. But again, it's putting the right people to ask the right questions in place as you're going through that. And Michael, I don't want to like super get into it as we're running out of time, but if you want to connect with me, or I can go ahead and shoot you guys over a link to the show that I was talking about, and you can listen to a much more expert person than I am have the conversation about OT network engineering.
Great. Thanks, Dave. Yeah, we are at end of time. There's a bunch of questions that we didn't get to, but we're on LinkedIn. Feel free to reach out to us. Be happy to try to address them offline. And I wanted to thank everybody for joining today.